Welcome physics majors to this brief video on an overview of careers and opportunities in physics. I'm the advisor, Greg Wood, and I'll narrate this video. 5 subfields of physics that I'd like to highlight are biophysics, the study of the computational and mathematical properties of biological molecules, condensed matter, states of matter, magnetism, material properties and structure, astronomy and astrophysics, the study of the stars and space, optics, and particle physics. There are many career pathways in physics. This is a slide from spsnational.org, the Society of Physics Students, national chapter. And what you can see here is of the over 8,400 physics bachelor degree holders that were awarded in the class of 2015 and 2016, about half entered the workforce. About a third attended graduate school in physics or astronomy, and about 20% entered graduate school in fields other than physics and astronomy. Many went to engineering and professional programs like medicine and law. Of those who entered graduate school in physics, about 1 in 6 of all U.S. physics bachelor holders do end up receiving a PhD in physics, and about 1 in 12 end up receiving a master's degree. With a master's degree, about half enter the workforce and half continue graduate studies. So it's a viable path to get your master's first and then your PhD, but you can also go straight to your PhD in physics. And we've sent 3 students just this last year. After getting a PhD in physics, about half accept a temporary position called a postdoc, and I'll talk a little bit about that at the end of this presentation, and 40% accept a potentially permanent position in the private sector or at universities. The median starting salary for physics PhDs employed in the private sector is $105,000. This is a couple of years old. I think it's a little higher now. All right, the curriculum flow at CI, I know this looks a little complicated, but it's just Calc 1, 2, and 3. So we hope when you arrive at CI and you're majoring in physics, you're ready to take Calc 1. If not, that's okay. You can take another math class to get ready, but our curriculum flow chart starts here. After you take Calc 1, you can start the physics sequence, Physics 200, the general physics sequence. So there's Physics 1, General Physics 2, which is Physics 201, and General Physics 3, which is Physics 202. After you've done the Calculus 1, 2, 3 and the Physics 1, 2, 3 sequence, and especially after you've had ordinary differential equations, ODEs here, Math 350, which I've highlighted in yellow, you're ready to take our upper division classes. Now, ordinary differential equations is very important. If you're a transfer student to CI, you may have had this at community college, and we can talk about that, whether we can transfer that or not for the purpose of the physics major. I know it's not exactly the same class usually as our Math 350. Okay, so after differential equations, you're ready to take 301 classical mechanics, 305 thermal physics, 304 electricity and magnetism, and you're ready for quantum physics, Physics 400, as long as you've also taken modern physics, Physics 306. In addition, we're now excited to offer 2 new courses, Physics 351, Mathematical Methods in Physics, and Physics 352, Computational Physics. In terms of upper division lab, after you take Physics 201, you're ready to take our upper division electronics lab, Physics 310 Electronics. Our students also enjoy taking Physics 405, our upper division optics course, and Physics 410, our electro-optics course, both of which have labs. If you're on the path to graduate school, it might be worth taking as an elective Physics 401, the second semester of quantum physics, or Physics 306 solid state. There are many internships available in physics. There are a few listed here. NASA has a career pathways program. The National Science Foundation has a full list of RAUs, and I know I've research experiences for undergraduates, and I know I've emailed you about a couple of these. So RAUs, research experience for undergraduates, are programs where big research universities that have NSF grants can bolt onto it an additional grant application to mentor undergraduate students from non-research intensive universities like the Cal State system. Great experience. All of these programs are paid. The RAUs also especially help you get housing in the area. You're able to move almost anywhere in the country. The Jet Propulsion Labs in Pasadena have internships which you can apply for. USAjobs.gov allows you to search physics internships at many federal agencies like big national labs. And the APS, the American Physical Society, has a bridge program, and I believe there are other bridge programs which are one-year bridges between the bachelor's and PhD programs. So it's kind of instead of doing a master's. Additional resources are available from AIP, the American Institute of Physics. They have career resources. The APS, the American Physical Society, which has career resources. SPS National, the Society of Physics Students National Organization. And then there is I wanted to highlight a Careers 2020 document from the APS, which I think is worth reading the whole thing. It's not very long. This gives you an idea of the many subfields of physics. I talked only about a few, and the number of PhDs granted back in 2010, 2011. So there are many regions of physics. Condensed matter has the most PhDs. Back then, I think that's still true. But you can study any of these fields, and one that does not have a large number of PhDs, like optics, may be extremely valuable in industry. It just may be that there aren't as many programs in that area. So from the Bureau of Labor Statistics in the U.S. federal government, the median pay for physicists is $122,000 a year, and the job outlook is plus 9% over the next decade, which is faster than average, and the median pay for physicists rose 20% in the last 10 years. So I can say with some degree of confidence that the outcomes for physics are good in terms of careers. Graduate programs, either master's or PhD programs, are paid via teaching or research fellowships. Tuition is paid in full at PhD institutions, and most master's institutions have a limited number of tuition waivers. Master's degrees usually take 2 to 3 years to obtain, and PhDs 4 to 6 years, but sometimes longer. You can go straight to a PhD or do a master's first. Master's programs, generally, I'd encourage you to apply within the Cal State system. Our students have great success getting into master's programs within the CSU system. PhD programs, we'd encourage you to apply broadly, all over. And you can go either into a PhD in physics or engineering or related fields. So it is a good time to switch fields. Postdocs are temporary academic or rarely industrial positions. They're usually 1 to 3 years in duration. It's easy to move with a postdoc to anywhere in the country or even internationally, and it's easy to change your field of study. So just because you did a PhD in particle physics does not mean you can't do a postdoc in astrophysics next. A lot of the skills we learn are highly transferable. So it's a good time. It is a way to change field if that's your decision at that point. You can also postdoc in across disciplines in engineering, and that can be valuable as well. So thank you for coming to this virtual orientation. I'm Greg Wood. Feel free to email me or text me on my cell phone. Thank you.